Next to 3, I Atlas flares. For a few seconds, like a point source, it hovers not against the sky, but close to the comet, as if tethered. This isn't just another star. The catalogs are empty. This isn't a satellite. The orbit isn't right. This isn't a flare. The instruments are too different, the optics too different, the results too similar, and the worst part? The flares are coming almost simultaneously from several points around the world. At first, it looks like a coincidence. In one archive, someone notes a strange peak. In another, someone writes, "Check, there's a point nearby." Within an hour, there are many such marks. Within 2 hours, a time coincidence appears. Within 3 hours, the angles begin to match. From this point on, history ceases to be mere astronomy, because anything that could be attributed to the instrument falls apart when the same symptom is observed by telescopes that are completely unrelated to one another. Different cameras, different sensors, different filters, different continents. An amateur in Canada catches a strange dot in a series of 20 frames. He has a simple setup, a telescope, a camera, and careful guiding. He thinks it's a hot pixel or a stack glitch, but the dot behaves too intelligently. It doesn't sit in one place on the sensor, it's sitting next to a comet. Then those accustomed to relying solely on numbers chime in. A European network of small observatories puts out a call. Who has raw, unprocessed frames around 317 to 321 UTC? And almost immediately they receive responses from Spain, the Czech Republic, and the south of France. The dot is there, at different exposures, with different filters, and for everyone. It doesn't appear constantly, but in short bursts, as if someone opens a curtain for a second and then closes it. And most importantly, the dot's position remains constant relative to the coma. If it were a star, it would remain in the sky, and the comet would move past. If it were a defect in the sensor, it would remain in place. If it were a satellite, it would cut into the frame, change the angular velocity, and leave a trail. Here, everything is different. The dot moves. With the comet, it maintains its distance. Sometimes it shifts slightly, but not as much as a background star shifts when tracking an object. Not just nearby, it's consistently nearby, like a small, neat neighbor on the same beam. Right now, something is happening in large structures that is never publicly visible. Not a press release, not we're looking into it, but short chains of messages in which no one argues over the wording. They argue about how bad things are. Because big telescopes have a habit. They check the simple ones first: artifacts, diffraction spikes, stray reflections, internal reflections from filters. And if the simple ones don't work, silence ensues. Not because there's nothing to say, but because you can't speak loudly. The first thing professionals do is demand raw data. No pretty pictures, no contrast enhancement, no tail painting, just fits, just the header, just the precise mechanics, time, temperature, orientation, focus, noise model, and then something emerges that breaks the usual logic. The file headers show perfect discipline, the frames show normal field photometry, and only this dot behaves as if it chooses when it's visible. It's brighter for a split second, then it disappears, then it reappears. The pulsation isn't like an atmosphere. The atmosphere breathes chaotically and ruins the entire field. Here the field is stable. The stars don't twinkle the same way. Only the false star twinkles. Someone says, maybe it's a micrometeorite cloud near the nucleus, a dust cloud that occasionally spills into the line of sight. But then it should be fuzzy. It should have a shape, albeit small, but not pinpoint-like. And here it is, a dot, a nearly perfect PSF. Some say maybe it's a background star, periodically obscured by the comet's tail. But checking the catalog and the before and after frames shows there's no source of the required magnitude in that spot. Zero, emptiness, as if it was never there. Some say maybe it's a reflection from the comet itself, some kind of shine on a fragment. But the shine on a fragment won't be so geometrically consistent. It will depend on the phase angle, orientation, and rotation. And here, the inclusions are too clock-like. Then comes the question no one wants to ask first. If it's not the background or the device, then it's something close to the object. Separate, small, fast, and controlled. And this is where the real mechanics of fear begin. Because near the comet isn't a poetic phrase, it's a measurable quantity. Astrometry gives distances in arcseconds, and when those arcseconds are converted to kilometers at the current distance, the resulting scale sounds all too familiar. Not thousands of kilometers, like random debris in the tail, not hundreds of thousands, like a dust plume, but tens of kilometers on the order of. This is the zone where everything is no longer tail, but accompaniment, and at this point, a most unpleasant thought occurs to one of the analysts. If the object was following a smart trajectory, if it maintained a strange orientation, if it showed signs of a regime, then how can we be sure it arrived alone? Usually thoughts like these aren't written in letters. They're expressed over the phone, because the letter remains. But the night is long, people are tired, and someone still captures it in a memo with a short phrase, co-moving point source, an accompanying point source, moving, not a background, not an artifact, not a glare. And when this phrase appears in several independent chains, those who don't like plots join the story. They only like threats. New fields are appearing in data requests. Not give an image, but give guidance telemetry, give drift, give matrix temperature maps, give solar panel orientation, give everything you don't normally show to anyone. By morning, a table of coincidences already exists in the private chat. Rows are for the observatory, columns are for the flash times, and the table looks as if someone was hitting the same spot with a hammer at the same intervals. The most dangerous thing isn't that they saw the dot. The most dangerous thing is that they saw it at the same time. This eliminates the processing error theory. Processing errors are different for everyone. Hardware errors are different for everyone, but coincidence is the same for everyone. Then they do what they always do when they're scared. They try to fit the phenomenon into a familiar box, and they only have 3 boxes: a natural satellite, a fragment, or a man-made object. A natural satellite near a comet sounds nice, but it doesn't hold up well dynamically. For something to stay close, it needs to be gravitationally bound, and a comet's gravity is weak, too weak to keep a satellite tens of kilometers away without it spreading out. A fragment is also bad. A fragment lives like garbage. It crumbles, spins, degasses, blurs. It won't be a point. It won't turn on and off. It won't look in the same direction for different observers. There's a 3rd box left, and no one wants to put data in it until they check one more characteristic: polarization. If the source reflects sunlight, the polarization will look like dust. If the source itself is luminous, the polarization will be different. And then the first truly hard evidence appears. In one set of observations, under a narrow filter, the dot behaves as if it were not reflecting, but emitting, faintly but distinctly its own. Not a shine, but a backlight. This isn't proof, but it's a blow to all the soft theories at once. Because if an object near a comet itself emits energy, then it has energy. And if it has energy, then it has a reason to expend it. At the same time, someone recalls an old practice in space navigation, when a spacecraft doesn't just fly, but flies in a group. One object is the carrier, the second is the observer, the third is the relay, and sometimes you see not the carrier but a beacon, and then a hypothesis is born that sounds too rational to be comfortable. A false star is a tracking beacon, a small object that maintains a nearby position, measures environmental parameters, and periodically pings the space. Why ping? Because if you're flying through an internal system and want to understand how you're being viewed, you put a sensor nearby, it sees what you don't see, it receives what you don't receive, and it can operate silently. And this is where the second layer of anxiety begins. Because if there's a beacon near Atlas, then there's also communication geometry nearby. And communication geometry always depends on the observer. That is, on us, on Earth, on when and how we look. And then the flashes in the coincidence table begin to read differently, not as random, but as a response. Too short to be picked up by radio amateurs. Too rare to be constant, but enough for someone up high to say, yes, it's active. At this point, the story splits into 2. One path is scientific. It requires more data, more time, more caution. The second path is operational. It requires silence, filtration, control, and a single version for the public. And the second path usually wins. Because if people hear there's a moving beacon near the comet, tomorrow half the internet will be building antennas, catching the noise, writing, "We found a signal," and any real signal will be drowned out by a million fakes. And that night, the first action appears, one that conveys fear better than any words. The most convenient bits of raw material begin to disappear from public view. Not all of it, not crudely, but precisely. What remains are beautiful shots where nothing is visible. Those where the false star shines through most clearly disappear. But it's too late, because these images already exist in private archives. They've already been downloaded, already copied, already forwarded to closed groups, and now the question isn't whether they can be hidden. The question is what they actually are. And the most unpleasant answer is formed not by fantasy, but by dry dynamics. The object maintains a position near the comet because it is adjusting it. It doesn't simply observe, it participates. It is small, but it is enough to provide a microscopic impulse. Microscopic for us, but not for a trajectory of millions of kilometers. Because trajectories favor small forces. Small forces that act for a long time change everything. And if the false star is the actuator module, then Atlas isn't just flying, it's being controlled. It's not the end yet, it's just the moment when the room becomes quiet for the first time. So quiet that you can hear someone in a report stop writing the words possible and likely and start writing consistent with, Because two questions need to be answered next. Why does the beacon turn on precisely when the Earth is in the correct geometry? And why does it hold its position so confidently as if its task is for the next few hours, not centuries? The first thing a serious team does is stop arguing about images. Images are deceiving. They switch to what's harder to deceive: spectrum, polarization, time, and frequency. And they start asking for observations that are not beautiful, but accurate. Optics says there's a dot near the comet. Radio should tell you whether the dot simply reflects light or whether it has its own process. And that's where something that almost never makes it into public collections comes into play: the millimeter wave. ALMA doesn't give an answer right away. That's because ALMA doesn't like plots. It needs a window, stable weather, and proper calibration. But when a window appears, they do a short session almost as a test, and they get a strange line. The line is narrow, too narrow to be a comet's tail. Cometary ejections create width, turbulence, and velocity spread. This is a needle as if the source were small and neat, with no chaos within. The second shock comes with Doppler. The line is shifted, but shifted as if the source were moving with the comet. Not like the background, not like Earth, not like a satellite. It's a velocity coincidence that's extremely difficult to explain away as random. Someone tries to exhale and say, okay, maybe it's a dense gas clot. It's producing a narrow line. But a gas clot doesn't maintain a stable frequency line if it's located in the tail. The tail is always noisy. There's no noise here. Then they do what they always do on nights like this. They assign tasks by frequency range. Some take optics and polarization, others go infrared. Still others try to detect X-rays. Still others listen to radio waves not in millimeters but in centimeters. And the same motif is repeated everywhere. Not we found a signal, but we found a regularity. Regularity doesn't have to be strong, it just needs to be stable, and it turns out to be stable as if someone were holding the parameter in their hand. The simplest test is done on polarization. If the dot is a reflection of sunlight from dust, the polarization should be cometary. If the dot is self-radiation, polarization is either absent or behaves differently. And it does behave differently. The signal appears and disappears, but the polarization angle doesn't fluctuate as the atmosphere does when it appears. It holds. The pattern is too stable for what should be random dirt near the core. This isn't about beauty anymore, it's about control. Almost simultaneously, another small detail appears, making the overall picture heavier. The dot doesn't intensify smoothly like a star on a clear surface. It comes on gradually, as if someone is choosing a threshold and opening it. A few hours later, they have a graph that no one likes to show to management, because the graph resembles telemetry, not astronomy, in bursts, in even blocks, with equal pauses, without random jitters. They're trying to blame it on the comet's rotation. They say the dot appears when the correct side is facing us, but then the period should match the estimated rotation. But it doesn't. The pauses look like a separate rhythm. And then someone says quietly, almost silently, it's like a lighthouse that runs on a schedule, not on physics. The words are simple, but the meaning is nasty. A schedule isn't about ice. Damn. A schedule is about a task. By morning, two hypotheses emerge in closed discussions, both bad. The first, it's an autonomous tracking module that measures the environment and synchronizes the maneuver. The second, it's not a module, but a communication effect, meaning the point is the end of the beam. If this is the end of the beam, then the false star may not be a body, but a knot in the structure of the ejecta, a small region of plasma or dust held magnetically and glowing when a pulse passes through it. And this version is starting to appeal to too many people, because it explains several things at once. Why the point is a point, why it stays close, why it turns on step by step, why a narrow line appears in millimeters, like in an organized process. But this version has a chilling condition. To keep a node in a loop tens of kilometers from the core, a mechanism is needed that lasts more than just a minute or an hour. It must be running constantly. And it must be inside the system. This means that either the comet has a magnetic architecture, like an artificial probe, or there really is a separate device nearby that maintains its position. Both options lead us far away from the dirty snowball. Everything then comes down to one question: why is this visible in several places at once, and why at the same time? Random phenomena don't synchronize across continents. What synchronizes is what lives, not in the atmosphere, but in the object. And then they start watching, not when they're lucky, but when it turns on. They build an observation window around the flare schedule. They want to catch the next one under ideal conditions and check whether the spectrum changes at the moment of activation. The next flare comes almost perfectly according to forecast, and this already sounds like a joke. Because astronomers are used to predicting eclipses, not inclusions near a comet, but here they manage to predict precisely the inclusion. At the moment of the flare, an additive appears in the spectrum that doesn't resemble ordinary cometary molecules, not because it's alien in name, but because it behaves like modulation, not like chemistry. The line width barely changes. What changes is the intensity. That is, the source doesn't heat up or cool down, it simply switches, like a lamp, and this ruins yet another attempt to explain everything with thermodynamics. If it were a piece of matter, it would enter the mode smoothly, with inertia. Here, there is no inertia. At this point, people who aren't romantics enter the conversation. They say, if it's a switch, then there's power. If there's power, then there's energy accumulation. If there's accumulation, then there's a cycle. If there's a cycle, then there's a purpose. And then comes the most troubling working model. A false star isn't just a beacon. It's a marker that gives an object its orientation relative to Earth. It activates when the Earth is in the right configuration to pinpoint its precise direction. Not in the sense of photograph, but in the sense of set the geometry. Because if you want to perform a scan, an exchange, or any precise maneuver near a planet, you need an external reference point that's independent of your body, and then the flashes begin to read like protocol points. A marker appeared, the direction was checked, the correction was accepted, switched off, waited, repeated, almost the same way our calibration systems work, only on a different scale and in a different silence. That same day, a soft normalization began in public channels. A tame explanation emerged. Processing artifacts are possible. No details, no raw data, no discussion of timing coincidences. But for those who've seen the coincidence table, this doesn't matter anymore. They understand one simple thing. If it's an artifact, it shouldn't be synchronous. If it's an artifact, it shouldn't maintain its position relative to the comet. If it's an artifact, it shouldn't have its own rhythm. It's rhythm that becomes the key. Because rhythm can be compared to other rhythms, to the rotation of an object, to its streams, to its scanning patterns, and at some point a terrifying connection is found. The false star activation intervals coincide with the moments when the Atlas jets change configuration. Not always, but often enough that it's no longer random. It's as if the marker is activated at the moments when the mode switches. If this is true, then the dot isn't an observer, it's part of the control system. It switches on when the object changes its dynamics, and that means we've been looking not at a comet all this time, but at a system that can change its modes right next to us. At this point, history begins to fray, making it difficult to keep calm, because near us isn't a metaphor. It's a distance where any system operating according to protocol already takes us into account as a factor. Not because she's evil, but because we make noise. We shine our radars, we track with optics, we clog the airwaves. We become the brightest source of technological noise in the vicinity. And if the object measures something, it measures us too. Right? Continue. And I'll pick up where they're trying to check one last thing. Whether the false star stays in the same spot relative to the comet, or whether it's making microscopic maneuvers that will give away its nature once and for all. Continue part 3. If it holds on, it means it has traction. The first question they ask themselves immediately is the dot really standing next to Atlas, or does it just appear to be standing there because of how we're looking? If it's an illusion, it will fall apart on the geometry. If it's an object, the geometry will only strengthen. Such verification requires not a pretty shot, but astrometry. Position relative to the star field, a series of images, strict errors, atmospheric control, and most importantly, 2 observation points, separated by enough distance to prevent parallax from being swept under the rug. They're collecting data typically reserved for hazardous asteroids, a worldwide network. Southern Europe, Chile, Hawaii, Australia, plus orbital ones, where there's no air movement. Everyone gets the same task, to capture the node and the comet on the same timescale. The first rows of data arrive in dry lines. RA/DEC, error, time, filter. And here's where the worst begins. The point doesn't float relative to the core, like dust in a coma. It holds its angle and distance better than it should. At first, everyone tries to avoid drawing conclusions. They say, maybe it's a star in the background and the comet is just passing nearby. But this theory quickly dies, because the dot's position moves with the comet. Not across the sky in general, but right next to it. Then parallax comes into play. If the point is distant, it will be the same on different continents. If the point is close and tied to a comet, the difference will become noticeable. And a difference does appear. Small, but statistically pure. This is the moment when silence usually falls in the room. Not panic, but the silence of people who know the value of 2 sigmas, 3 sigmas, 4, and who see that there isn't just one series here, but several at once. They recalculate everything, change reference stars, throw out bad shots, run a different pipeline. The point still remains nearby, as if it has its own trajectory, stitched together with the ATLAS trajectory. The next test is even more stringent. Does the distance to the point change discretely in steps at the very same moments of switching on? Not the brightness, but the position itself. If this is a device, it can make micro corrections before the pulse. And here they catch what the reports call a residual pattern. The remnants of the best model, a micro drift back and forth that almost coincides in phase with the flash rhythm. Too precise to be noise. In the language of celestial mechanics, this sounds simple and terrifying. There's a weak but controlled thrust. It doesn't necessarily have to be an engine like ours, but there is a force that corrects the situation and then delivers a controlled impulse. After this, the false star ceases to be a beautiful metaphor. Within the group, it begins to be called something else. Marker, repeater, node, satellite. The words are different, but the meaning is the same. A separate unit is working nearby, and yet there remains a gap that can't be filled with speculation. Where does the energy come from? If the node flashes and bursts and holds its position, it either draws power from the object, has its own battery, or draws energy from the environment. The simple reflection option is no longer viable. Reflection doesn't create parallax, doesn't support micromodes, and doesn't switch in stages. Reflection doesn't produce a narrow line that behaves like a switchable source. Then the next model appears, and it's unpleasant not because of its science fiction, but because of its logic. Atlas isn't alone, it flies in pairs. A large body and a small eye, positioned to the side, allowing for unobstructed observation and calibration of the entire process. We do the same thing when we want to measure near a bright source. We move the sensor away from the light source to avoid blinding it, and synchronize it using a precise protocol. The only difference is that the scale is different here, and the surrounding silence is too dense. When the model is formulated, it explains several previous oddities at once: why the signal is more stable than the coma, why the flares occur on schedule, why the activation times coincide with jet reorganization and scanning patterns. But the model has a new tooth. If it's a remote eye, then it has a purpose, and its purpose isn't to glow beautifully. Its purpose is to measure, and most likely to measure what's most powerful nearby. Us. That same day, someone suggests another check, almost a last line of defense for common sense. If the node is physically connected to Atlas, there should be at least some kind of dusty jumper or tail between them. If the node is autonomous, there won't be any jumper. They push the contrast to the point of indecency, cut out the background, stack frames, and extract everything they can. And they find the subtlest hint of structure between the core and the point. Not a thread, not a cable, but a faint but persistent path of particles. This isn't proof of a connection in the engineering sense, but it is confirmation of a shared mode. It's as if the node is sitting in a corridor where the flow creates a shield, power, or channel for it, and then the flash begins to be read as part of the exchange. And then comes the phrase, no one likes to say first. If it's an exchange, then there's data. If there's data, then there's an addressee. And the question to whom sounds stupid, because the most obvious addressee in the area is ourselves. They return to their rhythm and take a bold step. They try to superimpose the flash intervals on windows when major ground-based radars and communication networks are particularly active, and they find coincidences. Not perfect, but all too frequent. No one says he listens to us out loud, because that's not a scientific statement, but a political bomb. But in the tables, it looks as if the node activates precisely when the noise in our technosphere is at its highest. From this point on, NASA no longer officially hides anything, but rather begins to operate according to old protocol. Simplify the public picture, cut details, smudge deadlines, release only what doesn't connect the dots. Inside, however, a different conversation is taking place. If the node is autonomous, we can try to detect it differently. For example, by capturing not the light, but the radio signature of the pulse, not the frequency of the molecules, but a narrow artificial peak. And here's where the story reaches its breaking point, because the next step is already dangerous even as an idea. To test a radio spike, you need to listen in the right place and at the right time, or better yet, try to provoke a response. This is what they discuss at the end of the night, whether it's possible to send a short, safe, technically scientific pulse toward the object, which in theory doesn't violate the rules but creates a marker, and see if the node responds. The decision is born not from courage, but from fatigue. When you have rows of astrometric data lying on your desk and a false star is holding its position near Atlas, you either close your laptop or go all the way. They call it a calibration pulse. They choose words that can be repeated at a meeting without provoking hysteria. Not call, not check contact, but simply put a mark. The plan is simple to the point of being crude. First, passive listening to get a sense of the background. Then, a short, predictable pulse, in the range where the Earth is already noisy. And then silence again to observe the reaction. The most frustrating thing about such plans is that they never coexist within the same department. Astronomers see light, engineers see telemetry, the military see reflections, and communication specialists see noise, and everyone speaks their own language. So the first thing they do is what they usually do before a major disaster. They distribute tasks among independent sites. Some use optical sensors, others use radio, others collect geophysical data, and still others maintain the communications channel. Optics aren't needed for aesthetics, but to capture the microshift of a point against the background of stars. Radio is needed to see a narrow peak that doesn't look like noise. Geophysics is needed to filter out coincidences on Earth. The most serious risk sounds trivial. If they call and the target responds, it can't be unseen. If they don't, they'll lose a day and still be left with the same question. They choose a window when Atlas is above the horizon at 2 nodes simultaneously. This ensures that the response is confirmed not by just one observatory, but by at least 2. The same logic as before. Synchronicity kills excuses. Within NASA, this isn't done as an order, but rather as a chain of approvals. First, a risk assessment. Then a check for impact on civilian communications. Then, we don't do this. We do this. We do this silently. And yet, someone always makes the most important point. If there's a remote node near the comet, it might be more than just a sensor. It might be an eye that chooses what to photograph and when. That's why they're bringing in serious optics. Not because it's pretty, but because precision is essential. Hubble isn't in safe mode this time, but it's being given a narrow mission and a narrow window. ALMA receives a dedicated line. Not a broad spectrum, but monitoring a single zone. It's not interested in molecules, but in the sudden appearance of something narrow and repeating, as if a source had been switched on. Ground-based telescopes face an even more challenging task. They must shoot with a single filter, at a single rate, without any enhancements or automated processing. No artistic choices, only raw data and independent pipelines. The night before the window, the group lives on coffee and short phrases. No one argues about the words aliens and the like. There are no fantasies. There are only tables, errors, and the irritating persistence of periods. 2 hours before the pulse, they perform a check. The dot is in place. The brightness is stable as if it has a hold mode. Nearby, the coma and tail behave more lively, but not as neatly. And then the first nerve-wracking thing happens. Over 5 frames in a row, a tiny asymmetry appears around the dot. Not a tail, not atmospheric blur, but rather a tiny beak to one side. Some would call this an artifact. But an artifact doesn't repeat in 2 different places on different cameras. But here it does. And the direction matches the direction of the previous scanning scan. They register this and remain silent. Because if this is the orientation, then the node is rotating. And if it's rotating, then it's not just shining, it's working. The pulse is given at a predetermined moment. It's short, formally neutral, and has a clear signature, so there's no argument later about whether it was an airplane signal. Everything is as sterile as possible. Nothing's happening outside, no flashes in the sky, no light show. And that's even worse, because silence always leaves hope for chance. 10 seconds pass, 20, 30. The dot on the optics doesn't change brightness, and someone exhales as if they've just avoided disaster. And then comes the radio line. First, there's one peak, almost at the detection limit, then a second, more confident. And the most disturbing thing, the interval between them follows the pulse structure, but with a delay. Not an echo, not a reflection from dust. It's a delay, as if the system received the signal, processed it, and responded according to its protocol. Too clean, too narrow, too focused. They start doing what they always do. They cut the data, look for leaks, check if they've picked up their own side lobe. They check the cables, the clocks, the time calibration. The problem is that the peak isn't seen in just one place. It's confirmed at a second site, with a different receiver and a different antenna. The errors there are independent, but the result is the same. At this point, the false star ceases to be a beautiful fear. It becomes a device that hears and responds. And the worst part is, it responds not into the void, but toward us. A second strike arrives on the optics after a delay of a few minutes. The dot's brightness suddenly changes by fractions of a stellar magnitude and returns, as if it were not a light bulb that had flickered, but a mode indicator. And yes, it looks as if the node acknowledged the connection. Not with words, not with a message, but by the fact that it changed its behavior exactly after the external signal, and did so in the same way for all observers. Then everything falls apart into 2 realities. One is public, where nothing happened. The other is internal, where the anomaly can no longer be discussed as a strange comet. because the comet doesn't respond to the test. The comet doesn't produce a narrow, delayed radio peak. The comet doesn't blink in a timed manner that coincides with the applied pulse. They're trying to keep a cool head, but the system inside is already in motion. If a node can hear, it has a receiver. If it has a receiver, it has processing. If there's processing, there's a target. And then someone asks a question that sounds too human for this room. If they answered once, why are they even showing up? Why are they showing up next to ATLAS instead of hiding in a coma? The answer comes not in words, but in movement. Over a series of frames, the distance between the dot and the core changes slightly. There's a slight drift as if the node has moved to a new position, and the drift isn't chaotic but directed. It's as if the eye is adjusting to the next mode, and this next mode is no longer about the sun or the comet. It's about the Earth, because the line of displacement lies on a vector that leads specifically to us. 3 minutes after the second radio spike, a dry command is sent into the system that sounds like bureaucracy, but in reality means one thing: stop all impulses and close the discussion outside a small circle. It's not fear that kicks in first, but protocol. Internal chat is truncated to a list of participants, logging is moved to a separate archive, and all uploads are marked so that it's possible to track who saw what. At the same time, they're launching a second, public line. Everything is dull and boring there. The telescopes are conducting scheduled observations, the object is exhibiting typical activity, and there's no data to draw conclusions. But the problem isn't the press release. The problem is that the silence loop is always late. While one part of the system is closing, another, out of habit, continues sharing footage with colleagues because that's how it's always been done. And that's where the leak appears, not in the news, but in the environment where people exchange raw stacks and argue about focus. One file, one short clip of a star field, one unadorned caption. In this clip, the false star does something that can't be explained by a glare. It doesn't simply fade in and out, it changes shape as if for a split second it becomes not a dot but a tiny line. The second platform confirms the same thing almost simultaneously: an independent camera, different optics, different air. And yet, at the same interval, this microstroke appears like the signature of mechanics. In the communications room, someone quietly utters the word modulation, not as a sensation, but as a diagnosis. Because the narrow peak, the delay, and the optical blink together seem too consistent. Now comes the worst part. If this is an answer, it was meant to be seen. It's too clean, too repetitive, too easy to capture with various systems. This thought shatters our conventional worldview more than any story about reason, because it speaks to something simple. Someone on the other side is taking into account our tools and our reactions. In NASA's command center, one of the managers tries to bring the conversation back to normal. He reiterates that reflections, rare geometries, channel overlaps, and timing errors are all possible. They respond to him with numbers, not emotions. 2 independent radio lines, 2 independent optical lines, the same delay interval, the same characteristic narrow peak, unlike the background. At this point, Hubble enters the conversation for the first time, as an object rather than a telescope. They recall the previous safe mode and how it happened just in time. Now it seems less like a glitch and more like a warning. That's why Hubble is being given a new, extremely limited task. No long series, no long exposures, only short bursts of frames to capture the dynamics of the dot near Atlas. At the same time, they're activating another major tool, one they don't like to mention publicly in such stories. Military radars are once again switching to passive mode part of the time to avoid provoking a response. They don't need to send a signal. They need to see if the reflection changes when our background changes. And if it does, that means the object distinguishes natural noise from active interaction. While they're constructing this meticulous experiment, the world outside is going about its business, and that's precisely why things are getting worse. Because at the same time, strange messages are being transmitted to various points around the world. Not a single end of the world, but a series of localized emissions. Magnetometers are recording short bursts, seismic networks are picking up weak but synchronous waves, and meteorological services are simultaneously increasing their warnings. Each fact individually can be attributed to the season, statistics, or just a coincidence, but together they begin to look like a backdrop that someone is shifting to test our reactions. And then a third hypothesis arises, the most dangerous one. The false star isn't just a beacon, it could be a control unit, working in conjunction with the comet as a remote sensor and repeater. If so, the comet becomes not a body, but a platform, and the point near it becomes not a satellite, but something that maintains orientation, synchronizes modes, and possibly selects observation targets. A division is emerging within the group, not based on convictions, but on nerves. Some want to immediately cease all active efforts, because we've already had the answer, enough. Others say the opposite. If we stop now, we'll be left with half the picture. The object will be gone, and the next window could be decades away, if there's one at all. The debate ends not with a compromise, but with a new fact. Hubble is sending back a batch of frames, and they show that the dot has shifted relative to the nucleus, but not like debris in a coma. The shift is smooth at a constant speed, like a shift to a new orbital position, too smooth for a dust particle and too gentle for chaotic gas, which should blur the structure. And the most unpleasant thing is that the new position turns out to be more convenient for observing Earth. Not closer, but geometrically more advantageous. It's as if the node selects an angle at which our planet is more visible. At this moment, a silence falls in the room. Not a formal one, but a human one. Because the question is no longer, what is this? It's, why is this here, and why does it act so confidently? The silence loop is starting to expand. Not outward, but inward. Even adjacent commands, which usually receive data automatically, are being restricted. The risk that someone will upload the raw data again is too great, but it's too late. Private individuals already have the material, and it's spreading through closed channels faster than anyone can catch it. And it's spreading not as a sensation, but as a subject for analysis. They see what the professionals saw. The same form, the same moment, the same drift. And then a new detail emerges. One that the big teams missed due to their discipline. In one of the amateur shots, at the moment of the blink, a second, very weak source appears next to the point like a shadow, which appears only for a couple of seconds and disappears without a trace. And this shadow doesn't sit still, it behaves like a connected element, as if the node had a second component that briefly switches on when the mode switches, like a service module. Comparisons of footage from the two countries don't appear on mainstream platforms, but rather where people aren't sharing a sensation, but rather gathering evidence. Two raw files, two different sensors, and the same moment, matched down to the second. They smooth out the star field, remove jitter, pinpoint the comet's nucleus, and then do a simple thing. Overlay the frames in difference, and in the difference, something that can't be mistaken for a flare emerges. The false star doesn't just intensify over a short interval, it seems to change shape. In one frame, it's a dot, in another, a thin line, in a third, a dot again. It's as if the source unfolds a narrow pattern for a split second. The second, weak source, which they initially considered noise, is repeated in both cases. It appears in the same relative position, as if connected to the first, like a secondary stage that only activates when the mode switches. If it's an optical artifact, it doesn't have to be the same on two different lenses. If it's a dust reflection, it doesn't have to be so disciplined. And if it's electronics, it doesn't have to paint the same on different continents. Inside NASA, this package goes to people who don't write press releases. It goes to those responsible for unscheduled events, and they look at it the same way they look at telemetry before an accident. The decision is made quickly and without fancy words. From that moment on, the object ceases to be interesting. It becomes an uncertain factor that behaves with feedback. It's at this point that the tone of all conversation shifts, not outwardly, but inwardly. Publicly, it's still no grounds, but internally the wording is different. A possible accompanying component, a possible control dynamic. They're expanding Hubble's window. Not for a day or a week, but for short bursts with different filters to capture the spectral fingerprint of a point. They need to determine whether it's reflected light or radiation. At the same time, they begin to tweak the ground-based heavyweights, very carefully. On paper, these are routine observations. In reality, they're hunting for one parameter, whether the source maintains a fixed position relative to the comet. The VLT is tasked with high-resolution observations of the nucleus's vicinity, not to see the ship, but to measure microscopic shifts, which at such distances should normally be dirt, not a trajectory. ALMA is being asked to repeat the spectrum, but this time not for the tail, but for a nearby point. If there are lines there, it's not a star in the background. It's something that either glows on its own or is excited in a way that the background isn't. And here comes an unpleasant detail that no one wants to mention out loud at first. If the dot is associated with a comet, its position should change to maintain a convenient geometry for observing Earth. They take the ephemerids, calculate the phase angles, look at where our planet is relative to the comet at those hours, and realize that the dot's drift actually improves the line of sight. It doesn't make it closer, it just makes it more convenient. This is precisely what most undermines the random theory. Randomness can produce strangeness, but randomness rarely optimizes for a specific task, especially at the moment we're looking at it. During this same period, military radars pick up another fragment of the image. Not a picture, but a signature. The reflection remains narrow and stable, as if it were reflecting not from a cloud but from a surface with a constant orientation. Then the reflection worsens for a few seconds as if the object absorbs the pulse, and then returns to its original state. and someone in the room, quietly, without pretense, says, maybe it's shielding. This word sounds terrible precisely because it's mundane. Shielding is done by things that have an internal logic to protect themselves. Comets don't do that. Dust doesn't do that. Chaos doesn't do that. NASA's next step seems cynical, but it's almost inevitable. They're trying to test the object's reaction to our noise without sending a direct signal. They're changing schedules, changing windows, changing the background, seemingly by accident. If the system reads our coordination, it must adapt, and it does. Not abruptly, subtly, but enough that the match statistics start to look bad. The dot next to Atlas repeats its blink, not randomly, but during periods when large instruments are simultaneously on the target. It's as if the node only switches on when it's sure it'll be seen. This chills even the calmest of minds, because it doesn't mean we found something strange. It means something strange has found us, and it's already integrated our telescopes into its cycle. A new concept is emerging within the team that no one wants to bring to the surface. Demonstration mode. Not as a show, as a test of our ability to capture and interpret correctly. And then a terrifying question arises. If this is a demonstration, where is the line? You can demonstrate something harmless, or you can demonstrate something that will force us to make a mistake. At precisely this moment, another familiar pillar begins to break. Strange coincidences in weather and geophysics are indeed occurring around the world. Not an apocalypse, but a chain of local extremes. Someone is trying to reassure everyone with statistics. December, storm season, background seismic events, geomagnetic fluctuations. It sounds reasonable until you plot the time of the blink near the comet on the graph. The coincidence isn't perfect, but it's unpleasant. Too many peaks end up within the same narrow intervals. It's as if there's a shared metronome, and it's not ours. Nobody says a comet causes earthquakes. That would be stupid. But people are starting to think about something else. Synchronization. If an object is capable of working with plasma and magnetism, it can introduce noise into the environment. And the more they think about it, the less they want to actively test hypotheses, because active testing implies intervention, and intervention with an unknown system always ends the same. At the same time, the public sphere begins to crack. Journalists don't see the data, but they see the absence of data. They see that windows are closing, that the answers are identical, that nothing unusual is repeated too often. And against this backdrop, the old story about Hubble's safe mode resurfaces. It emerges not as a fact, but as a pattern. Just right at the window, just right at the key moment, just right at the most crucial sequence. NASA is forced to make a move that looks like it's concerned about transparency. They're releasing a couple of neutral frames and a general brightness chart where everything looks normal. But this only raises the stakes, because private owners compare what's published with what they have, and they see that the very moment is missing. Not covered up, simply missing, as if the most inconvenient part had been cut out. After this, events begin to unfold according to a scenario no one controls. The word filtering appears in private chats. The word hiding appears in public comments. But inside, in the real rooms, a completely different word emerges: evacuation of responsibility. Because if this is truly something controlled, then any subsequent step will be something for which they will later be judged. Night brings no relief, it brings repetition. The false star lights up again next to Atlas, and again, for a split second, it becomes a streak. And again, the faint second component appears, like a shadow, and now they have something they didn't have before. 3 series, 3 repetitions, 3 identical intervals. This is no longer an incident that can be brushed aside. They construct a hypothesis that sounds as dry as possible. 2 connected elements, a primary source and an auxiliary one. Periodic mode switching. Possible directional transmission. And here you asked, what exactly is this? The scariest theory isn't about a star or a satellite. The scariest theory is about a communications node that hangs near the comet like a remote beacon. If the comet is a platform, then the point could be what measures us, synchronizes our modes, and does what the stone cannot. It chooses the moment, chooses the angle, chooses the way to be seen. And if that's true, then there remains one question no one likes to ask. Who is this beacon for? For us, because we're watching. Or not for us, because we just happen to be in the coverage area.